Okay, now compute the total flux of this vector field on this surface. The surface is formed by two pieces. The first piece is a paraboloid, okay, up and down, and the second piece is the bottom part, que is a disc. It's a disc of the radial one, no? Because this is one and one, the intersecting one. Okay, let's go to the formula. The flux is the surface integral vector field that uninormal vector ds. Okay, this is equivalent to write double integral minus p gx minus q gy plus r dx dy, like a double integral. Suppose let's focus in the surface one. In the surface one, gx is minus 2x, gy is minus 2y, no? Okay, so we have a double integral in the region D. Okay, by the way, the region D is the disc of the minus p, this is pqr, this is minus x times minus 2x, okay, is gx minus y, gy is minus 2y, because q is y and r is c. But you cannot write c, you can write 1 minus x squared minus y squared, because any variable we're using in the double integral is just x and y, no? dx dy. Okay. Let's see the algebra here. It's minus 2x squared minus 2y squared plus sorry, this is positive. Double negative positive, double negative positive. This is positive. Plus 1 minus x squared minus y squared. And when you combine like term, this is x squared plus y squared plus 1. That's the expression itself. Okay, let me continue here. Here. The double integral. The double integral is double integral. The integral function is x squared plus y squared plus 1. Dx dy or dy dx, doesn't matter, dA. But the domain is the into D. It's a unit circle. This is the domain. This is much better doing polar. It's obvious that it's much better. This is D. This is D. Let's compute this in polar. In polar, this is r squared plus 1, r dr d theta, and r varied from 0 to 1, and theta varied from 0 to 1. Okay, I want to skip the evaluation of the integral, then the evaluation of the integral is 3 pi over 2. Okay, this is a flux through the surface one. Let's move on to the surface 2. Well, surface 2 is different because surface 2, the normal unit vector is like that. It's like a 0, 0, negative 1. Therefore, see our vector field. Let me write here. See our vector field is f x comma y comma z, when you perform the dot product of the vector field and the normal vector, que es this, the answer is just negative c, no? But by curiosity, in this surface, any point in this surface C is 0. Therefore, the flux is 0. But the final answer is flux, total flux, net flux is 3 pi over 2. Final answer. Okay, again compute the flux of this vector field on this surface. It's obvious that the best way is the graphic parametrization, no? And the formula, where I want to copy the formula again. The flux and the surface f of the vector field dot unit vector ds is equal the double integral in the region D of the formula que es minus p gx minus q gy plus r. dx dy or dy dx, dA in general. Okay, let's go. Let's go to the surface. In the surface I can find a gx, partial derivative of this with respect to x, is partial derivative with respect to 1 here, is 0, fy. And partial derivative with respect to y is 6y minus x. Super. Okay, let me set out that part, the integral. So it's the double integral. Let me focus on the integrand function. Minus 3y, because p, this is pqr, 3y times y minus y, que es gx, minus x, que es q, 6y minus x plus 6 dx dy. Okay, this is algebra. Minus 3y plus 3y squared minus 6xy plus x squared plus 6. Okay. Therefore, our double integral is minus 3y plus 3y squared minus 6xy plus x squared plus 6 dA, no? dA. What is the D region? This is the D region, the shadow, the projection here. This is a square, like that, xy. 0 to 1, 0 to 1. This is D. Suppose I select the order of the integration like that, dy dx. So the integration in that direction, and after expanding this, say y vary from 0 to 1, and this vary from 0 to 1. And this is super easy, compute this. It's too long, but we'll just skip. The answer is 13 over 3 is the final answer. Okay.